Hello friends, welcome to the channel of Digital to Real. Today I am going to discuss about the system Verilog interface. We know in Verilog the communication between blocks takes place through the ports. We have input port, we have output port, we have in-out port, so we have many signals. When we have many IPs interacting with each other, so manually we have to make the connection between the IPs. That is a very rigorous job. So interface is a construct which has been introduced in system Verilog in order to encapsulate or group together the similar type of signals. It helps to increase the reusability of the verification component used in the test bench, and it helps with the communication with the duty or the design also of the verification component. So interface encapsulate connectivity. So instead of using the separate signals in order to make the connection between the various IPs or various blocks, we have a single item. A single item will be replacing the names of the group of signals. Interface actually reduces the amount of code needed in order to model the port connections, and hence it increases the maintainability and the readability of the code. Let's see the intermodule communication for a Verilog style. Here I have a master module. I have a slave module. Here are the ports which are connected: data, address, request, grant, ready, clock. Now I am writing the master module, module master, where I have put input clock, in out 31 down to 0 data, output 15 down to 0 address, output request, input grant, input ready. So these are the set of signals or ports available with master. So here the connections have been done in detail. Now here is the module slave. For the module slave, here is the ports available in the port list. Input clock, in out 31 down to 0 data, input 15 down to 0 address, input request, output grant, output ready. Here also the connections in the slave have been done in detail. So this is how the signals have been put in master and slave. Now the same signals I will put in the module top. See, module top, input clock is there in the port list. Then what I have? Wire 31 down to 0 data, wire 15 down to 0 address, wire request, grant, ready. Okay, now master has been instantiated as I1 and slave has been instantiated as I2. And all the signals which are available in master modules, they are connected with the signals in the top module. Similarly, slave is instantiated I2 and all the signals in the slave are connected here in the top module signal. So here the connections are made in ordered form. Now the intermodule communication I will show you through interface, which has been introduced in system Verilog. Same master module is there, slave module is there, and bus is the name of the interface, and the bus, actually the interface, encapsulate the signal: data, address, request, grant, ready. Okay, clock is separate, clock is not there in the bus interface. Now how to write the interface? Interface, name of the interface bus, semicolon, wire 31 down to 0 data, semicolon, logic 15 down to 0 address, semicolon, logic, request, grant, ready, semicolon, end interface. So these are the set of signal that is used with the master module. Same set of signal will be used with the slave module also. Please note the direction I have not put here, and for direction in the interface we make use of the mod port that I will discuss later. But now please see, these are the signals which is available both in master module and both in slave module, and the name of the interface is bus. So I will make use of an instance of the bus and put it in the master module port list. Same bus instead I will put it in the slave module port list. Here you see module master, interface IO underscore bus. Here the interface is IO underscore bus. There is a port list. In the port list I have put a IO underscore bus, and the IO underscore bus I will connect with the instance of interface bus in the top module. But here IO underscore bus is of interface type. Module slave, here is the module name, slave, module slave is there. Here also in the port list I have put interface IO underscore bus semicolon end module. Okay, IO bus is of interface type. Now in the top module, module top input clock semicolon, bus is now interface bus is instantiated here. IO semicolon, instantiate the interface. IO is the name of the instance. Now this IO I will connect where? In the master I will connect master I1. Okay, so in the master I1 I will this IO I will connect in the, this IO bus is there, no? IO bus here I will put. So I will pass this IO for the port list. So clock is not included. So clock I will separately put here semicolon. Slave I2 instance is there. Here are also the instance of the interface IO I will pass it in the argument in the port list of the I2, which is of slave type semicolon end module. So what we are doing, connect the interface instance to the module port. This is what we are doing. So now I am going to talk about interface mod port. What is mod port? So modules port direction definition are moved within the interface using the mod port keyword. So we saw in the interface bus set of signals we have provided. Logic, wire were the data type of the signals. But the directions we have not provided. The interface, those signals, they were going to be used in master and slave also. So the direction of the signal in master is different. Direction of the same set of signal in slave is different. So the direction with respect to the master and with respect to the slave is provided through the keyword mod port, which will be included inside the interface. Let's see how. So interface bus semicolon, wire 31 down to 0, data semicolon, logic 15 down to 0, address semicolon, logic request grant ready. So this is same as the previous interface bus. Now mod port master ports. Mod port master ports. So mod port name is master ports. For master, the ports, the signals, I have provided the direction. Input data, comma, output address, comma, output request, comma, input grant, comma, input ready, semicolon, bracket close, semicolon. So this is the direction with respect to the master. Now mod port slave underscore ports. So in out data, comma, input address, comma, input request, comma, output grant, comma, output ready, bracket close, semicolon, and end interface. Here the slave port, the signals, what I have provided the direction with respect to the slave. So address is input to the slave, request is input to the slave, grant ready are the output from the slave, and data is of IO type, input output type. So a mod port defines the port direction from the module's point of view. So now what I will show how to use the mod port definition. Okay. So the system Verilog has two ways to select which mod port to use. We will see how the mod port is used. First one is that at the module instance allows generic module ports. Generic module ports. This is first type of usage. We will see through example. Interface bus, mod port master port, mod port slave port. Okay. And interface. Internal details I have not provided. Now you see. Module master. In the port list, interface IO bus. End module. Module top. Input clock. Bus IO. Semicolon. So instance of the bus interface. Now the master. Module master is instantiated in top module. I1 is the instance name of the module. Now the connection you see. So IO dot master ports. IO dot master port is the mod port. Is the mod port master port. This is how the connection are done. IO dot master ports, comma, clock, bracket close, semicolon. This is the generic way of mod port connection. Okay. Earlier we saw where the mod port was not there. Master I1 IO, comma, clock, semicolon. So now we have provided the direction of the signals. So master ports. This is how the connection is done. Now number 2. At the module instance prevents incorrect connection. Now you will see. First one was as the module instance, generic connection of the mod port. Now we will see the incorrect, in order to prevent incorrect connection, what to do. Interface bus, same mod port master port, mod port slave port and interface. Same. Now module slave. Now how the connection has been done. Bus dot slave ports IO bus semicolon. So connect to interface using the slave ports port list. There in the top module, master you see, module master interface IO bus. Here it is a generic name of a interface. But the connection of the generic name has been done in module top. Okay. IO bus, this port list have been replaced with IO dot master ports. Okay. Now here module slave and end module. So module slave is there. The connection is not generic. Bus dot slave ports and IO bus is of type bus dot slave ports. So connect to interface. Here the connection has been done to the interface using the slave ports port list. So inside the module top, input clock, same in the module top, in the port list input clock. Input clock is not there in interface. Bus IO, interface bus, IO is the instance of that, semicolon. Now the slave is instantiated. I2 is the instance name of the slave. You see the connection, only IO is passed here. Comma, clock, bracket, semicolon. So here IO dot slave port is not provided here. Direct the connection we have done here. So what it does, it prevents incorrect connection. We spoke about mod port, we spoke about only mod port we spoke about. Now we will talk about interface methods. So interfaces can contain methods also, defined using Verilog or system Verilog task and functions. So the interface will have task, function, these it can have. And this method used to encapsulate the intermodule communication functionality. What this interface method does? They encapsulate the intermodule communication functionality. So you see, interface bus, semicolon. So here I have a task read. Here I have a task write in the interface. I have a function bit parity, parity gen. Bit parity gen, parity generator function is there, read and write task are there. So these are the communication method, intermodule communication method available in interface bus. Apart from the task function in the interface, I have the mod port master ports, import, read, write, input. So what input, output, these are the signal list, okay, that is there in the master ports. But we are importing the task and function also in the master port. This master port which will be used in master module. So there we are importing the read, write and the bit parity gen, those task and functions also, apart from providing the direction to the signals. Similarly in the mod port slave ports, mod port slave port is the name of the mod port. Here also I am importing the read, write, parity gen, all this task and functions I am importing. Apart from that, the signal list as it is, the direction of the signal used in interface block with respect to the slave. And here is the end interface. So this is how the methods have been put, interface method have been put inside this interface and interface. Now referencing signal and methods in an interface. Okay, referencing. So we have seen in interface we have signals, we have method. Now we will see the referencing. So modules can reference signals. Modules can reference signals and method within the interface using a hierarchical path. Till now we have not seen the referencing done through a hierarchical path. We directly included the master port and slave port in the where we use in the top file, module top file. For the master instance and the slave instance, we directly included the bus.master ports, bus.slave ports. Those we have included, but we have not done the hierarchical path name reference. So we can do it like this: interface port name dot signals and method name. Okay, interface port name means instance of the interface dot the signals and methods. We will call hierarchically, we will reference hierarchically. See how. We have the module master, interface IO bus. Okay, the connection of the port here, interface the port. Now inside the module master I have a always block. Always at the rate of passage of the clock begin if IO bus dot request reference the signal in interface. IO bus dot read here reference the method in the interface. For this begin, this is end. For this master, this end module. So this is how we are referencing the request and read. Request is the signal, read is the method which is available in the interface bus. Okay, and the connection with the interface IO bus of this master module will be done from the top level module top. So hope this interface in system Verilog is clear to you. If you like the video, please share with your friends. Please subscribe the channel and have a very nice day.